Hello everyone. Let's continue with the chapter probability. In our previous class, what we have done is the basic first the definitions of probability, the theory part, and then we moved on to do the sums that included only the basic probability definition that's favorable by 2. If you're picking up, for example, you're talking about coin or dice, we directly find the probability using the sample space. In case we have something else, for example, it is you're choosing an object, one object, then we can again do it directly. But if you are choosing more than one object, then we use combination. Okay. Now, we're going to learn a different concept of probability, that is conditional probability. Conditional probability. Okay. Now, we will be finding the probability under a specific condition. Okay. Now, what will happen is there are two events. One is A and the other is B. So, we need to name them first event and second event according to as what has already occurred and what is about to now happen. So, when we find the probability of an event B, when we know for a fact that another event A has already occurred, that is known as conditional probability. Finding the probability of an event B when another event A has already occurred. So there is formula, but majority of the cases will be using just normal common sense. Understand? For example, in a bag, I have 5 red and 7 white balls. I picked up a ball. Okay. I picked up a ball and I found that it was white in color. I threw it aside. And then from the remaining bag, I pick up another ball. What is the probability that it is going to be red if white has already been selected? Has already been selected. So, how do we write probability red given white? That means one white ball has already been selected and taken out. Now, from the remaining, what you are doing is you are picking up a red ball. So that means the white count has reduced by 1. So now in my bag, I have 5 red ball and I have 6 white ball. What will be the probability of this? What is the probability of getting a red ball now?
5 by 11.
5 by 11. Understood, everybody?
Yes, ma'am.
Suppose from a deck of cards, we know about that 52 cards, 2 colors, 4 suits. I pick up a card. I pick up a card which was found to be ace of diamond. I pick up a card which was found to be ace of diamond. I threw that away. From the remaining, I pick up another card. From the remaining deck, I pick up another card. What is the probability that I'll get a red card given ace of diamond was already selected? Can you tell me the probability?
25 by 51.
Very good. So in total 52 cards, but I already took out one card. So now the total number of cards are 51. Ace of diamond is also red in color. So earlier there were 26 red and 26 black. One of the red card I took out. So now the count of red card has got reduced. So it will be 25 upon 51. If I would have written probability black card if ace of diamond was already taken out, what would be the answer?
26 by
50.
All of you understood?
Yes, ma'am.
So
Yes,
this
ma'am.
slash is basically your conditional probability symbol. Whatever is written on the right side of the slash, that has already happened. So if I write probability B given A is my first event which has already happened. B is the second event whose probability I'm asking you to find. So in some cases, we use common sense. Like in this, did you use any formula? No, it was a normal common sense question. Okay, this has already taken out, so the count is reduced to this. Now from this remaining count, I'll need to find out the probability. So with 5 by 11, 25 by 55. So we don't need any formula. In some cases, we have to use the formula. So have to learn the formula also. Let's write down. Did you understand the basic concept of conditional probability?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So the probability of an event B when another event A has already occurred is known as conditional probability of B given A. It is denoted by probability B given A. Understood?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now, A is the first event. Whatever is written after given, after if, after when, which has already occurred, is your first event A. B is the second event whose probability we are asking to find. So when we read the question, okay, from conditional probability, there will be three varieties later on also coming up. We have total probability, we have Bayes theorem. So we have three varieties of question. Till now, whatever question you have done, you were only given one event. What is the probability of getting two head? What is the probability of getting an even number? What is the probability of finding a total of 7 number or points? So you are given only one event whose probability you have to find. So that is normal favorable by 2 pi. Now in all the remaining questions, you will be given two events. For example, black card has already been drawn. What is the probability of getting another black card? Okay, so I've given you two and I've mentioned what are the two probabilities for what are the two events. First one was getting a black card already done. Now you are finding another black card or you are finding another red card. So yes, there will be two events and both will be mentioned. What you want in the first event, what you want in the second event, both will be clearly mentioned to you. And then you find out the probability of the second one. So when there are two events, it will be either conditional probability or total probability or Bayes theorem. I'm only taught you till now conditional. In conditional, both the events will be mentioned. First, I want black card. Second, I want red card. First, I want black card. Second, also I want black card. I'll tell you both the events. When I mention both the events, that this is what I want in both the trials, then it is a case of conditional probability. Understood?
Yes, ma'am.
Yes, ma'am.
So formula here is, in majority of the cases, we won't use the formula, but coin dice, we use the formula wherever sample space question comes. And in some cases, you'll see that you have to use the formula. The question is all about formula. So this is intersection by first event. Intersection by first event. I'll tell you, there is a very easier way to write. Okay. Before moving forward, if A and B are independent, can you tell me what are independent events? What are independent events?
Occurrence or non-occurrence of an event does not affect the other occurrence.
Yes. And mathematically, what do we get? Every intersection can be written as
Product of the probability.
Product of A.
in that case, B given A. The formula is intersection by A. Instead of intersection, what can we write? Probability of A into probability of B. Probability of A gets cancelled. We are left with probability of B. So B given A is same as probability of B when if the events are independent. Obviously, common sense. If B is not bothered by A, then why do I even, for example, what is the probability that you will get head in a coin if 1 has appeared in the dice, does it matter that what we have got in dice?
No.
No, ma'am.
It is same as finding the probability of head. So what is the probability of head? Half. So even you tell me a conditional probability, in this case, it doesn't make sense because they are completely independent of each other. It doesn't bother them. So in this case, even if you ask me a conditional probability, it is same as normal probability. So in MCQ, they ask you that if A and B are independent, then which of the following are true? Or they'll tell you if probability of B given A is same as probability B, then A and B are independent, mutually exclusive, exhaustive, equally likely. Which of the case? It has to be independent. If conditional probability is same as a normal probability. Understood?
Yes, ma'am.
Yes.
Yes, ma'am.
Now, how do we do the sums? Okay, how will we be doing the sums? For example, question: a dice is thrown 2 times. As soon as I write a dice is thrown 2 times, that means how many outcomes are there in total?
36.
36. 1116, 2126, 3136, that way. Okay. Probability 4 appears given sum is 7. Given sum is 7. Okay. What is your first event?
Sum is 7.
Sum is 7.
Okay. So in a dice, how many numbers give you a total of 7? In dice, how many numbers give you a total? Sum of the numbers to be 7. In one, we have 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. How many people?
6.
6. So first event is written in the denominator. Now numerator, we write intersection, right? So what we do is, now from only this, you don't need to take the entire sample space. Only from these 6 answers, you tell me which one satisfies your second condition, because we are talking about intersection. Intersection means both the conditions has to be satisfied. So first condition, sum is 7, is only satisfied by these 6 people. So whoever satisfies the second one also in these 6 will be your numerator. So how many out of these 6 objects satisfies the condition 4 appears?
2.
2.
2. So answer is 2 upon 6. Understood?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Probability 2 appears if a doublet. That means what has already happened?
The doublet.
Doublet. What are doublets?
1, 1, 2, 2,
Same.
3.
1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So how many?
6. ma'am.
6. So denominator will be 6. Now out of these 6, in how many 2 appears?
1, ma'am.
1. So answer will be 1 by 6. Understood?
Yes, ma'am.
So
Yes,
you write
ma'am.
the first event in the denominator. From the first event, whoever satisfies your another event, another condition, write the one in the numerator. Clear?
Yes, ma'am.
All of you clear?
Yes, ma'am. Yes, ma'am.
Now, from here we have theorem of compound probability. We don't really use it. It's just for theory, huh? Of compound probability. So the formula for B given A has already occurred. From here we have intersection. So from here, if I cross multiply, A intersection B can be written as probability of A into probability B given A.
Yes, ma'am.
This is compound probability. Or we could have also written, what will be formula for A given B?
Probability A intersection B by probability
By
B.
Probability B.
So from here, intersection will be probability of B into probability A given B. Understood? So
Yes,
these
ma'am.
two are known
Yes,
as
sir.
theorem of compound probability. Just remember the line. In sums, we don't really use it. Done?
Yes, ma'am. Yes, ma'am.
Okay, let's continue with the examples. Example 1515. Page 1519. Page 1519. Rupesh is known to hit a target in 5 out of 9 shots. So probability Rupesh hits the target will be,
5 by 9.
whereas David is known to hit the same target in 6 out of 11 shots. So probability David hits the target,
6 by 11.
6 by 11.
till here any doubt?
No, ma'am. No, ma'am.
Okay. Now see, for example, if I am and Darshini are playing dart, we are throwing the arrows. Supposingly Darshini's arrow hits the bullseye. Will it affect when I throw? Will that information affect when I throw, keeping the emotions aside?
No, ma'am.
No.
Same vice versa. For example, I threw the dart, it didn't hit. Okay. So will it affect the way Darshini throws the dart?
No, ma'am.
No.
No.
Whether my dart will hit the target or not, whether Darshini's dart hits the target or not, it solely depends upon our individual capabilities. So, our hitting the bullseye or our arrows hitting the dart is completely independent of each other.
Yes, ma'am.
So, in this
Yes.
case, Rupesh and David's hitting the target is completely independent of each other.
Yes, ma'am.
So, in this case, the events are independent. Do you all agree? Problem solving, hitting the target, all these questions are independent. Okay. So, if I know that they are independent, then what can I find? Independent gives us a probability of, what does being independent give us mathematically?
Intersection.
Intersection. So probability R intersection D can be written as multiplication, 5 by 9 into 6 by 11, 30 by 99. Any problem?
No, ma'am.
Rest of you guys, is it okay?
Yes, ma'am.
So question is, what is the probability that the target would be hit? I explained you just a day before. What is the probability that the target would be hit? Target hit, work done, job done. All these questions are basically
Union.
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 Target hit is basically at least one of the person has to hit the target. At least one is always union. So target hit, job done, work done, problem solved, everything is union. So we have to find out union probability. Formula R plus probability of D minus probability R intersection D. So 5 by 9 plus 6 by 11 minus 30 by 99. Answer. Writing final
79 by
decimal,
99. 79 by 99.
0.79.
0.
79.
Everybody got the answer?
Yes, ma'am.
Yes, ma'am.
Okay. Now, the same sum could have been done in much smaller way. What was the question? That Rupesh hits the target 5 by 9 times, David hits the target 6 by 11. It says that the probability that target would be hit. So, what is that I don't want? I
Not
want the
hit.
target to be hit. What I don't want is the target should not be hit, right? Should not be hit by whom? None. So, probability target hit. Can I not write as 1 minus probability none hits the target? Can I do that?
Yes,
From
ma'am.
total probability is always 1. From that, if I remove the case where no one hits the target, I'll get the remaining answer. Yes, no?
Yes,
Yes,
ma'am.
ma'am.
Okay, so none hits the target. That means Rupesh does not hit the target. So if hitting the target is 5 by 9, not hitting the target is
4 by 9.
4 by
By
9.
David hitting the target is 6 by 11, not hitting the target.
5 by 11.
5 by
5 by
11.
11.
And I want both of them to not hit. So multiply. Rupesh should not hit and David should not hit. We could have done this also. 1 minus 20 by 99. Same answer, 0.79. Yes, no?
Yes, ma'am. Yes, ma'am.
Guys, understood?
Yes, ma'am.
Yes, ma'am.
Any doubts till here?
No, ma'am.
No, ma'am.
Okay, 15.16. 15.16. A pair of dice is thrown together and some of the points of the two dice is noted to be 10. What is the probability that one of the two dice has shown the point 4? That means, see, we are talking about two events here. What is the first event? What has already happened?
Sum of the dice is 10.
Sum to
Sum
be
is
10.
10. That has already happened, which is my first event. Now, what I want is one of the dice should show the point 4. So that means probability 4 appears given sum is 10. Do you all agree?
Yes, ma'am.
Yes,
So what
ma'am.
should I now do? You all explain.
Nine combinations where the sum is 10 and 4 appears
Okay.
harmonic.
Sum is 10 is how much? Sum is 10 is how much?
3.
4, 6, 5, 5, 6, 4. 3. Now what will I write in the numerator?
This is where 4
2.
appear
ma'am.
2.
4 appears twice. The answer is 2 by 3. Everybody understood?
Yes, ma'am.
Ma'am.
You
Yes,
don't need
ma'am.
formulas in these cases. You can directly do this. Everybody clear? Please try example 15.17. Everybody. Try example 15.17. Example 15.17 on your. Done?
Yes, ma'am.
So it says, what is the probability that the person selected at random from the group is a service holder given the selected person is male? So whatever is written after given is your first event. So we want service holder given male. So what we'll write is in the denominator male. How many male?
20, ma'am.
20.
20. Out of these 20 male, how many are service holder?
12, ma'am.
12.
Answer would be 12 by 20. Clear?
Yes, ma'am.
Guys, clear?
Yes, ma'am.
Yes, ma'am.
Okay. Now, 15.18, if you read the question, we have no choice but to apply the formula. We don't have a choice. So, it says probability of A, 2 by 3, probability of B, 3 by 5, probability of, sorry, they're saying something?
Oh, ma'am.
5 by 6. First, find out intersection. We know that union is equal to A plus B minus intersection. Find out probability A intersection B. Thirteen by 30.
Yes, ma'am.
Yes, ma'am.
I'm writing everything in denominator of 30 so that it's easier to do the calculations. 30. So 18 by 30. Probability A union B. 5 by 6. 25 by 30. Intersection 13 by 30. Now we will use them. First is probability A given B. What would be the formula?
Probability of A intersection B by probability B.
So A intersection B, 13 by 30, B 18 by 30, 30, 30 gone, 13 by 18 is answer.
Yes, ma'am.
All of you clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Next, number 2. Probability B given A. Intersection by A. Intersection 13 by 30 divided by A 20 by 30. So 13 by 20.
Yes, ma'am.
Yes, ma'am.
The third one. Probability A complement given B. A complement intersection B by P of B. What is the numerator? I don't want A, but I want B. A complement is not A and B. I don't want A, but I want B. That is what?
Only B.
Only B.
Only
How
B.
do we find only B? How do we find only B?
Probability B minus probability
A
A
intersection
intersection
B by probability B. So I'm removing all the denominators. 18 intersection 13 by B 18. So answer would be 5 by 18.
Yes, ma'am.
Yes, ma'am.
Try the rest of them yourself first. Did you try the next two?
B. Yes, ma'am.
Yes, ma'am.
Number 4, probability A given B complement, intersection by B complement. This will be A, not B. So only A. B complement is 1 minus B of B. This is 20 minus 13 by 30 minus 18. 7 by 12.
Yes, ma'am.
Fifth one, probability A complement given B complement. So intersection by B complement. So taking complement common, it gets reversed. This is 1 minus probability A union B by 1 minus probability B. So 30 minus 25 by 30 minus 80. 5 by 12. Yes.
Yes, ma'am.
Everybody clear?
Yes,
Yes,
ma'am.
Example 1519. Example 1519. Read. The odds in favor of an event is 2 by 3. So what will be the probability in that case? Odds in favor was favorable by unfavorable. So 2 favorable cases, 3 unfavorable cases. So total 5 cases. Probability is favorable by total. So how much will it be?
2 by 5.
2 by 5. Odds against another event is 3 by 7. So unfavorable 3, favorable 7. So total
10.
10. So probability will be favorable by total.
7 by
3 by
10.
10.
7 by 10.
Probability that only one event occurs. Probability only one occurs. That means A occurs, B does not occur, or B occurs, A does not occur. Do you agree?
Yes, ma'am.
Yes.
Instead of intersection, we can directly write multiplication. Probability of A into B complement. Probability of B into A complement. You could have also done A minus intersection. So A 2 by 5. What will be B complement?
3 by 10.
Plus probability of B 7 by 10. A complement 3 by 5. 27 by 50. Any doubt?
No, ma'am.
All of you clear?
Yes, ma'am.
Yes, ma'am.
Example 15.20. Please read the question first. So it says that one ball is drawn from each box. You have to draw a ball from box 1 as well as box 2 as well as box 3. What is the probability that they will be same color? Then it means what? Either all the 3 bag will give me blue ball, or all the 3 will give me 1 red ball, or all the 3 will give me 1 white ball. Do you agree?
Yes, no.
So either I'll have 3 blue ball or 3 red ball or 3 white ball. So first, blue from the first bag. What is the probability? Getting blue from the first box.
5/23.
And blue from the second.
4/21.
And blue from the third.
3/16.
Plus red.
8/23.
Second also red. 9/21. Third red. 6/16. Or all the 3 white. First box white. Second box white. Third box white. Guys, any doubts? Any doubt?
No,
No,
ma'am.
ma'am.
Okay, try. Calculate first. Calculate this. Calculate this. Guys, answer.
1052/7728.
Done.
Yes, ma'am.
Yes, ma'am.
Example 15.21. First, you try yourself. Done. Mr. Roy is selected for 3 posts. For the first post, there are 3 candidates. So the probability of her being selected will be
1 by 3.
1 out of 3. Second post, there are 5 candidates. So probability of her being selected 1 by 5. Third post, there are 10. So her being selected is 1 out of 10. What is the probability that Mr. Roy would be selected? So can be selected in 1 job, can be selected in 2 jobs, can be selected in all the 3 jobs, right? What I don't want is none. What I don't want is none. So total minus probability none selected. Total minus probability none selected. The person did not get selected in any of the jobs. So 1 minus the first job, Mr. Roy did not get the selection, 2 by 3. Second job, he did not get the selection, 4 by 5. Third job, he did not get the selection, 9 by 10. Yes?
Yes, ma'am.
Answer?
13 by 25.
Clear, everybody?
Yes, ma'am.
Yes, ma'am.
Okay. Your homework is still 15.26. 15.26. Actual part of the probability is done. What we are about to start in the next class is a very different topic, completely new. So it has no connection with us. Probability was still here. Everybody clear with this? Make sure
Yes,
you
ma'am.
revise all the topics. Tomorrow we'll also do a couple of extra questions. Okay. Bye guys. See you.